Hello calculus students. In this problem we're going to compute the length of this vector, which is the linear combination of 2u minus 9v. Now the information you have is the length of u and the length of v. You're also given the length of u plus v. So we need to determine what is the length of this linear combination. Now you may be wondering, where do we start? How do we figure this out? Well, one thing you can do is you can expand this length computation here, because you'll know that it will involve the length of u and the length of v, and from that you can determine what u dot v is. Once you have all that information, you have the length of u, the length of v, and you have u dot v, you could expand this term out and do the computation from there. Okay, so let's go ahead and do that. So the first thing I'll do is realize that the length of u plus v squared is u plus v dotted with itself. That comes from the fact that, if we recall, that the length of a vector squared is equal to the dot product of the vector with itself. Now, knowing that, if I take u plus v dot u plus v, then I'll have u dot u, which is there. I'll have v dot v, which is there. And then I'll have v dot u plus u dot v, but because of the commutative property, that is just u dot v plus u dot v, and I'll get 2 u dot v. So it looks like a FOIL. Okay, the first outside, inside, last has taken place here. Now remember that u dot u is the length of u squared, v dot v is the length of v squared, and I have 2 times the dot product u dot v. Now I just substitute the values in. The length of u is 5, the length of v is 3. And then recall that the length of u plus v quantity squared is the square root of 13 squared. So that tells me that u dot v is minus 21 over 2 if I do the following calculation, right? 5 squared is 25, 3 squared is 9. Add those together, I get a 34. Subtract that from each side. Square the square root of 13 to get 13. 13 minus 34 is minus 21. And then I divide by 2, and I have u dot v is equal to minus 21 over 2. So I have an obtuse angle here between the vectors. Just recalling that. The angle between two vectors is given by the dot product and the norms of the vectors. Okay. Now, we have enough information, knowing the dot product and the lengths of the vectors, to actually do this computation. And here's how that unfolds. If I square the length of this linear combination, that once again will be 2u minus 9v dot 2u minus 9v. Once I perform that dot product, it's just like multiplying binomials. I'll have 2 times 2 is 4, u dot u. 9 times minus 9 times minus 9 is plus 81, v dot v. And then I'll have minus 18 gives me minus 36, u dot v. U dot u is u length of u squared, v dot v is the length of v squared. U squared is 5 squared, v squared is 3 squared, and then I just get u dot v, which I did in this previous calculation, which is minus 21 over 2. And then I just perform the multiplication and the additions, and I get that the length of this linear combination squared is 1207. Now I take a square root of both sides, and I get that the length of this linear combination is the square root of 1207. So to recap, the workhorse idea here is that the length of u is u dot u. So whenever I have even a linear combination of vectors, if I take the length squared of a vector is u dot u. If I have the length squared of even a linear combination of vectors like u plus v or 2u minus 9v, I take those vectors, the linear combination of those vectors, and I dot them with each other. And then I just perform the respective dot products and then plug in the subsequent information. All right. Well, good luck.